To most people, there are exactly 24 hours in a day, the ground only moves during an earthquake, and the Earth rotates just like it does on a globe. And generally speaking, that makes sense. But scientists who like to find out exactly what's going on know the ground actually moves around quite a bit. Days are never quite 24 hours, and the Earth actually wobbles on its axis in a very particular way as it revolves around the sun. Scientists know all this by using a technique called very long baseline interferometry, which is basically a fancy term for using radio dishes to very precisely measure the Earth's orientation. VLBI was originally developed back in the 60s to take pictures of quasars. Early on, though, someone realized that because quasars never really move, you could use them as reference points, throw the whole process in reverse, and figure out how all the telescopes were moving relative to one another. Basically, when a quasar emits a radio wave, that wave reaches different telescopes at different times. For astronomy, you'd use a computer to imitate a giant telescope and get a good picture of the quasar. But if you instead pay close attention to the time differences, you can use geometry to figure out how far apart the telescopes are. And by making lots of those measurements, you can start to see how the ground beneath the telescopes moves around, when you have to adjust your clock, and that the Earth wobbles on its axis as it moseys around the sun. So the next time you feel like you've had a long day, or that your house is a few millimeters from where you last left it, you can switch on a bunch of radio telescopes, point them at quasars, and find out just how right you are.